we go. So don't break my heart. I'm trying to keep my heart in one piece. So, graph paper. That's a daily thing. I should not have to invite you to get graph paper out. It's okay that some of us were late, especially if Miss Swihart gave you guys new seats. I know that takes some time. If you did not turn in 3.2.5 and 3.3.1 yesterday, you need to, because I'm going to put them in math today. And y'all might just get lucky for the fact that you have morning class with me, and you have another chance to get it turned in. But it's not like, even when things go in math is missing, it's not like the end of the world. Just turn it in and then your grade changes, right? It's not a big deal. I'm still kind of giving grace and not putting the timeliness mark on those. But guys, if you can't turn those in, come to math lunch. Today we're focusing on Chapter 2 follow-up, but we only have a couple more problems to do from that, so we will have time to work on homework as well. So if you are missing these in my grade book, I am, kind of halfway anticipating I might see you for lunch, okay? Today, we're doing 3.3.2, actually, like we talked about, where this board was more accurate than this. You do not need to change this in your plan book. What is happening? Apparently, it wanted to insert my page from the other slide. Why I have this little picture of Colonel Sanders right there, and yes, it is not KFC, but it's KCF for Keep, Change, Flip, is we're going to have a mini mastery tomorrow on division with fractions, like Keep, Change, Flip. It's going to be small. So nothing to be worried about. Guys, I am about to have to evict some of my no-name papers because there is no space left on my board. I'm all the way up onto this top strip. Look at all these papers that people don't care enough to put their names on. Put your name on your work. If you're missing something, come check the no-name board. I need papers to go away, right? I need papers to go away. There's no space. If you didn't turn in homework, you should probably come to math lunch. Here's that letter if you need it again. Here's your formal invitation to math lunch. Insert your name and invite yourself to math lunch. So, let's chat about that KCF thing. So, on your paper, we can go ahead. If you want to give it a header for today, what we're actually heading our work today. I don't know why I just made a new page so I can just show this. This, right? We said this is always our header. So today we're going to talk about decimal division because we have been talking about fraction division, but we know that fractions and decimals are really the same thing. So I should see pencils moving, writing down 3.3.2 decimal division instead of people just staring at me counting how many hairs are on my head. Right? Like what? I don't know what you're doing staring at me. It makes me feel weird when you're supposed to be writing stuff down. Every human feels a little weird when a bunch of people are staring at them. At least like when you're supposed to be doing something else and people are just like, and you have to tell them like, write this down. That's when it's weird.
I thought you were a robot.
Right? So, KCF, John, not KFC, is on purpose. If you look real close, this says keep, change, flip. Somebody just, did a little Photoshop to the KFC image. But guys, we want to still make sure that we understand why in the world this works. So you don't have to write this down. But I was chatting with somebody at Extensions. Having trouble on your math homework? Come get help at Extensions. Another option. And I said something that they were just like, anytime there's that moment, it's worth repeating. Multiplication and division are reciprocal operations. They do the reverse of each other. Right? It's like, if I do 10 divided by 5, I get 2. But if I go the other way, I can do 2 times 5 and get 10. Right? Multiplication and division are the reciprocal. They're like go in different directions. Right? Like positive and negative numbers. So like 20 divided by 4 makes 5, but 5 times 4 makes 20. So this kind of leads to that idea that we talked about yesterday, where if you change the operation, we flip the number after it, because this operation has turned to its reciprocal, literally the operations with each other are reciprocal operations. So 5 turns to its reciprocal, and we get the same answer. Right? So a couple different examples of why keep, change, flip works. This you should write down on your paper, at least one of them, of changing division into multiplication or changing multiplication into division. Whichever you want to do, we can do both. You can go back and forth. You can change it into, multiplication and then change it back. If you had multiplication of a fraction and didn't like that, although we normally like multiplication with fractions. And how could we not talk about food to remind us about this? So, pizza. Do a cake? Okay. So, a pizza divided into 8 slices. Every slice is 1/8. That's the same as saying, hey, give me 1/8 of that pizza. Right? Give me 1/8 of multiplies 1/8. I get 1/8. I get 1 slice. It's the same thing. But I hear you. Okay, do a cake. Do a cake. So I get a cake for the class. Yeah, now that's impressive. You didn't know I'd be ready with a cake. If I bring in 1 cake, beautiful rainbow cake, I don't even know if I could bring myself to cut into that. But and there are 22 people in this class. When we split up, we're dividing, right? Or you could walk up and say, hey, Mr. Hudson, can I have 1/22 of that cake? Which would be a slice. Keep, change, flip. Right? Division into multiplication. We just flip that number over. We take its reciprocal. Any questions back about what we did yesterday with keep, change, flip? Okie-dokie. Now I need your guys' help with a project. So this says Mr. Garcia, but honestly, if you aren't aware that I like woodwork and stuff yet, you probably haven't been paying attention. At least not every day. So most nights when I go home, I fire up the saws. I'll move my wife's car out of the garage, fire up the saws, and start working on a project. Right now, I'm working on trim. The stuff that goes at the bottom of the floor. It's super annoying. Very precise measurements, because you can't just like cut it willy-nilly. It's got to be the exact right size. So Mr. Garcia is working on a project where he has a 16-foot long board. Let's go ahead and on our graph paper, because all of our work is on our graph paper today. Go ahead and put down that this is 98. And go ahead and write down that he's got a 16-foot long piece of lumber that's about as big as you can buy. It doesn't come much bigger because 16 feet's pretty big. 16-foot long board. This is how long the piece of wood that he has is. And that, like, you can't really buy much longer unless you did, like, special order delivered by a semi. That sort of thing. He wants to cut it into 9-inch long spacers. I want you to discuss with your group and then go ahead and try it. How could we determine how many 9-inch spacers or blocking, they're like things that you use to keep things a certain width apart. He wants them 9 inches out of a 16-foot long board. There's a trap door here. Chat with each other for a couple minutes. Depends on when. Which ones? You want to check my book? 3.3.2 and 3.3.3 did get passed out, so if you don't have tonight's homework, yeah, that's it. Anyone else that doesn't have 3.3.2, this problem is not in it, but this is tonight's homework. Cool. Anyone else need 3.3.2? I passed it out yesterday, but if somebody was out of the room or anything, What? Are you sure? Hey, we're doing random cards, so please make sure you're all talking with each other and you're all listening to each other. You're an O. O. What? Try to solve it. How many 9-inch long spaces can we get out of it? Kylie, can you help us identify the trap door here?
The trap door is that the 16 is in feet and the 9 is in inches.
Units. Our units are the trap door here because I heard people say, well, we can't just do 16 divided by 9 because that's feet, that's inches. 9 inches is about this big. 16 feet is like from me to the door probably, right? 16 feet is big. That might not even be 16 feet. So how many 9-inch pieces? We got to convert something. We can't do 16 divided by 9, so keep chatting with each other. What division are we actually going to do here? You can make it easier. There are 12 inches in every foot. 12 inches per foot. Every spacer is 9 inches. Less than a foot, right? 9 inches is less than a foot. So, pause. Hit the pause button. So Sloan walks up to your group. Actually went to a high school with a kid named Sloan. Sloan walks up to your group and he goes, dudes, fractions. We've been dividing fractions yesterday. Dividing fractions is what we just reviewed. And Sloan says, dudes, all you got to do, yes, Sloan likes the word dude, is do 16 divided by 3/4. 16 divided by 3/4, he says. Why? Chat with your team, but like, what? Where'd the 3/4 come from? It says it up here. If you don't know, you should read, and it tells you up here. How many inches are in a foot? 12. So the pieces we are making, on your paper, please write down 9 inches compared to 12 inches. What happens when I have inches over inches? I just can get rid of them. So I really have 9 over... Well, guys, can 9 over 12 reduce? Oh, Sloan, you fraction wizard. That's what he calls himself. He thinks pretty highly of himself. That's where 3/4 came from, because that's feet. It is 3/4 of a foot, because it's not a whole foot, right? It's 9 out of 12. The inches canceled, and we're now working in feet. So try to do this with your team. 16 divided by 3/4. How could we do that? And then we'll look at Audrey. Somebody has a different idea then, but let's make sure we can do this. It's not Kentucky Fried Chicken. It's Keep Change. So 16 divided by 3/4. We keep change, flip that, right? 16 divided by 3/4. get an answer to that, we'll compare that to these other answers that we get. They'll probably do the same thing. Remember, there's a lot of right ways to get to Florida. You took a different route than me, but could you get to the same spot? Yeah, you can get to the same place.
No, I get it.
Carmen, what can I do? You're good. What can I do with 16 divided by 3/4? Hey, hold up. I can't hear Carmen. Do what? Keep, change, flip. Before I do that, I normally make this into a fraction, right? But that's not a big thing to do. So 16 over 1 change to multiply. Careful, guys. If you thought about cross-reducing, we cannot do that till we're doing multiplication. And now there's not really any cross-reducing to do. So 16 times 4, do 10 times 4 is 40. Then do 6 times 4, 24. Like break up that multiplication, right? 10 and 6. So 10 and 6 multiplied by 4. So we get 64 divided by 3. Well, that's not terrible. Forget about the 4. How many 3's would be in 60? 60. 20. And another 3 can come out of the 4. And then what do I have left over? 1/3, right? Because 64 would leave me with a remainder. So it's really 21 and 1/3. So 21, right? He's got a little extra wood. And guys, if I'm being honest and teaching you stuff that like I didn't know till I got older, every cut you make, you lose a little bit of sawdust. So actually, you have to think about that when you're planning out cuts like this. You lose as the thickness of your blade disappears, right? When you make a cut, which like I didn't think about till I actually like was on a job and I was like, why don't I have enough wood? It's this sort of stuff. Like, so if he needed 22 pieces, does he have enough wood? No, he's got to go buy more. If he only needs 20, he's safe, he's good. But I don't know if you guys have any siblings that are like near your age or slightly older that you like kind of compete with. But every time I think about problems like this, I kind of think back to my sister where she would always be like, well, I have a better way. Even if I like have the right answer, she would try to be like, yeah, but you should do it this way. So up walks your classmate or somebody like that. And they said their name, but now I lost it. They wrote it like this: 16 over, like, divided by 0.75. So go ahead and on your paper, 16 over 0.75. I'm going to bump to my other page, though. So this classmate says, really, this is better. But Sloan being the fraction wizard says, absolutely not. You have a decimal inside of a fraction. Tisk, tisk. That is, we don't like that. It's not like wrong. We just don't like it. Right? Mixing decimals and fractions. It looks really weird. Yeah. So Sloan is like, oh, let's make that into a fraction. How do I say this correctly? 75 hundredths. So Sloan says, actually, we should have 16 over 75 hundredths. Go ahead and write that down. 16 over 75 hundredths. But I'm going to go ahead and name this other student Abby. We'll just pay homage to my sister. Maybe, but I'm going to throw some shade at my sister. And say, Abby then says, okay, but now you have a fraction in a fraction. Talk with your team about, like, is there a way to fix this or make it better? Or, like, what can we do here? Who's right? Just chat with each other for a couple minutes. What did we say yesterday a fraction is? Okay. That should be part of your conversation. That fractions are actually division. Fractions are actually division. Guys, do me a favor. This, let's not say that that's a fraction. Let's say that that is division. Right? Because we said fractions are division. So I'm going to rewrite this as 16 divided by 75 over 100. Do we know what to do with this?
Yes.
I sure hope so after yesterday. It's not Kentucky Fried Chicken. It tastes just
No, it's not.
different.
It's Kentucky.
It's not food at all. It's a math strategy. Yeah, I need to work on my song.
Yeah.
Okay, so we got to multiply across the top.
1,600.
Yeah, we just kind of put those zeros on the end, right? And then over. This isn't terrible, because 75 is not like a bad number. What could 1,675 both potentially reduce by? Well, that's the answer that we got before, but that's not the question I asked Ikshita. So listen, what could both of these numbers reduce by? Lucas? 25. Because, guys, 75 does not divide by 10 nicely. But it would divide by 25. So if we wanted to reduce this, we could reduce this. This will get the same answer, 21 and a third. But then, of course there's a but then. So guys, this is the same. It's another way. Same answer. But then. You got a classmate who's all about long division. It hurts to say. So go ahead and write down. Go ahead and write down. Put your long division symbol. 16 divided by 0.5. Right? How we read this is 16 divided by 0.5. But when we set up the long division, a lot of times people lose track of where the decimal goes. Like, so I guess I have a decimal here, right? But my question is, up here, does my decimal go like here or here or here? Like, so because we're not, I don't know. I haven't done long division in like years. So I want you to, as a group, figure out how can we avoid long division and instead try to set this problem up like a fraction. Or like something divided by a fraction, right? Like, how could we set this up differently to avoid long division? Or you might not have enough brains. Like, you might get a bigger blanket. You don't have stuff in your pockets. We can get a bigger blanket. Like math lunch or AO or extensions, I can probably get you a different blanket. Yeah. Because that 0.3 repeating is the same as 1/3. We said we're going to random card. Hey, Zeus, can you tell me how to write this? You're good. We'll give more time then. How do I say 0.5 the right way? 5 tenths. 5 tenths. 16 divided by 5 tenths. And then we can keep change flip. Now wait a minute. Hold on. Give me your eyes up here because I want you to ponder something with me. This is what we just got. And yeah, I can do that and figure out what it is. But guys, what I started with was 16 over or divided by, because we said division is a fraction, right? So division is a, how do I get from 16 over 0.5 to this? What happened here? Eli? How? I agree with you, but how's that happen? If we want to fix this, give me your eyes up here. If we want to fix this decimal, Eli said, if I multiply by 10, this decimal is going to move over, because 0.5 times 10 is really 5. So if I do it on top also, I fix it. This like fraction having a decimal in it, it's not wrong because I can fix it. As that's the trick. We don't even have to do this extra work. If we fix what we start with, I don't even need to do this work. I could just get to 160 over 5 because we multiply by 10 on top and bottom. There are tons of ways to do these problems. It's all about finding what strategy works for your brain. Okay, I'm not going to tell you which way is like the best way for you. I'll tell you my personal opinions. All of those have bias. So, here's our challenge, and we're only going to go as far as we need to. They say use your calculator. But I don't know. I think we could probably write these things down and like, I'm going to give you, how much time do we have? That's enough time. I'm going to give you 5 minutes to solve these problems. But I want you to have things written down on your paper, even if you use a calculator. I want you to write down like 1.5 divided by 0.25 before you write down the answer. Okay, so work as a group. Talk about like A before you move on to B. We're just trying to like get comfortable with some divisions. Obviously, 3 divided by 4 is like integer divided by integer, right? Number divided by number, what we're used to. Then it gets a bit more tricky, right? With decimal numbers and things like that. So go ahead and write these down. We're going to just like take a few minutes to play with these things. You don't have to write them all down to start. Just go one at a time. Just one at a time. I'll make this a little bigger. I have a feeling that even if we go without a calculator, we can like fix most of these. You guys are really quiet for working with your team. I'm going to even like leave the room and see if that helps you guys do some work. Because you're way too quiet. We should be talking with each other. We should be talking with each other about these things. If you aren't using a calculator, grab one. Start using one. I'm trying to be honest about 5 minutes, and it's so long. Well, probably all of us. Whoa, that last one is really weird. 0.0015 divided by 0.00025. Whoa. Alright, I'll scooch these as we need to. So let's compare like the answers that we're getting and just talk about these real quick. I almost made it to 5 minutes. Whatever, we're running out of time. So 3 divided by 4. If we set it up like a fraction, right? 3 divided by 4. What do we get as our decimal answer? 0.75, right? A lot of us know that one because of money, right? If we think about 3/4 of a dollar, right? 0.75, like 75 cents. So, but B, if we work our way over, B is actually over here, not down. If I set up 1.5 divided by 0.25, now I'm going to bounce back to Eli for a second. Since you were the one to tell us that little trick, how could I fix this one and make my fraction use like whole numbers, not decimals? Multiply by 100 to fix the bottom? Guys, what in your head is easier to solve? 1.5 divided by 0.25, or how many 25s are in 150? This is easier! Why would we try to do this when we could just do this? Guys, I'm here. I don't think I've said it this year as much as I've said it in other years. I'm here to make your life easier. Math is meant to make your life easier. We only give you difficult stuff so then it like becomes easier, or we find tricks or strategies around it. This is way easier. What do we get here? 6. Straight up 6. I can do it in my head. 6, 25, 50, 75, 100, 125, 100. I can count it on my fingers. Lucas.
I actually did it a different way.
How'd you do it?
So I took, I made it into a fraction, so 1.5 over like that, and then I did both of them times 4. Because
Ooh, to get over 1?
yeah.
Yeah. So Lucas realized I can multiply by anything, and Lucas says if you do times 4 on bottom, that becomes 1.
I apologize for the interruption. I need Mr. Shoup to the office, please. Mr. Shoup.
So what Lucas did real quick, you don't have to write this down if it's not what you did. It's just sweet, right? Different strategy. Lucas did times 4 on top and bottom, which gets 6 divided by 1, which we know that's just 6. Right? 6 divided by 1 is just 6. So down here, if you haven't written down 15 over 2.5 yet, what would we multiply by here to move the decimal once? 10, right? Times 10. Guys, at least a couple of these should get written down on our paper so it helps us understand how this makes sense. Wait a minute. 150 over 25 again. That's what we just had. This is the same thing. Those silly gooses. 30 divided by 40. Wait a minute. Who's sniffing that this smells a little fishy? It's the same thing as A. It's just 10 times bigger. So you got 30 over 40. It's going to get the same thing as A did. Even though they look different, it's the same thing. How do I... Well, I don't even have to talk about how to write this correctly if we're going to do that whole fix-it trick.
3,000.
So, well, hold on. 0.003, 0.004. How many spaces do I need to move this decimal? 1, 2, 3. If I move this one, 1, 2, 3. Okay, that's good. What is it? Guys, that's 3 over 4. It looks really complicated when it starts, but if we fix it, this would be times 1,000 times 1,000, right? On top and bottom to move it 3 places. It gets back to 3/4. It's the same thing, 0.75. Chat with your team, because I don't know if we've gotten this far. How do we fix this? What do we multiply by on top and bottom? Crap, sorry, 0.25. Or you can just really say, how many decimal spots do we need to move? How many decimal spots do we need to move? As long as you move the same on top and bottom. As long as you move the same on top and bottom. How many spots should it move? How many places do we want to move that decimal? 3, right? 1, 2, 3. 1, 2. Wait a minute, hold on. If I do the moving spots, what do I do when there's no number out here? Add a 0. So it's 150 over, oh, it's that same thing again. Silly gooses. G, not as tough as it looks like. 3/10 divided by 4/10. Guys, give me your eyes up here real quick. 3/10 divided by 4/10. I can write this however I want, right? Because we're good mathematicians. We're like, I've got better strategies. 3/10 divided by 4/10. What does this actually turn into? 3 over 4. Because we can do times 10 on top and bottom. Times 10 on top and bottom makes it 3/4. Same thing we've had. We could do the same thing here. You don't have to write this down, but here, work with me, think with me. 0. How many places do I need to move my decimal? 1, 2, 3, 4, 5. Nice. So do the same thing on top. 1, 2, 3, 4. Uh-oh. Gonna have to add a 0. It's the same thing. So guys, make decimal division easier. Make it easier. Doesn't need to be super difficult. Have a wonderful day. Mini mastery tomorrow, because I don't do pop quizzes. I tell you about it. Mini mastery tomorrow. Show you the what? 3.3.1? Yeah, I decided not to. If you can't do it on your own, you should come to math lunch.